Hello. The purpose of this video is to have a walkthrough of BF-Detector, a novel tool for detecting CI build failure. CI begins when a contributor makes some changes on the code base, then a series of tasks on CI server, such as Travis CI, will build and test and provide immediate feedback on the outcome of the change to the core team. If the tests are executed with success, the build will be passed and CI system can deploy the code to the mainline repository if core developers decide to accept it. However, when one or more of these tasks fail, the build is considered broken. Build failure represents a blocker that prevents developers from proceeding further with development, as it requires an immediate action to resolve it. In addition, the build resolution may take hours or even days to complete. For example, it has been reported that developers can spend 900 to 2000 hours to resolve broken builds. Another recent research has found that passed builds can run faster than failed ones, considering Travis torrent dataset. BF-Detector is a novel tool proposed to cut off the expenses of CI failure by detecting when the committed changes are most likely to fail. The idea is based on the adaptation of NSGA2, a multi-objective genetic approach, to generate a detection rule expressed as a combination of CI-related metrics and their appropriate threshold values, and should cover as much as possible the build results using the history of builds. To use BF-Detector, the first thing you need to do is to install Graphiz, a visualization tool. In addition, to run the tool, Java runtime is required. BF-Detector is available as a jar file that can be downloaded from the project's website. Use the command shell to run BF-Detector with the required arguments. First, the path, which can be a GitHub URL or the local Git path if it's located locally. The commits, which are the changes to be built separated by sharp, and the cross-project, which is an option set to perform the training based on an existing database from other projects. This option is recommended when the project is new or small. On completion, the tool returns its prediction for the build outcome. As you see in the screenshot, in this example, the build is expected to fail. The tool generates also a PDF file to allow visualizing the prediction justification. The file is located in the same path as the jar file. In this example, the build is expected to fail because the number of deleted files is greater or equal to 5, and the average experience of developers is less or equal to 1875 in terms of commit. To get more insights about the approach, you can have a look at the following research papers.